Okay, hello and welcome. So, my name is Trace, and um, we are gonna be um working on a really fun project today. Um, I have this controller that I've been working on, and I want to port the display driver over to MicroPython so I can publish it to GitHub. So let me go ahead and show you what I was talking about. Um, let's see. So, right. So I have this display driver that I have going right now, and let's give it a second while it starts. Um, there we go. So let me see if I can get that a bit closer to the camera. Right. So we've got some animations going on, and right. Okay. Yeah. I think it's like still initializing. Yeah. And also I've got a bad USB cable, so I've got to be careful about that. Oh, sorry about that. I think my USB cable is a bit stuck. And okay. All right. So um yeah, so this is based on the display is an ILI 9341 OLED display, and right, I wanted to run some animations as well as uh the UI and all of that, and also the firmware for the microcontroller. Um, but the issue is, so first of all, let's see. All right, so I think maybe we need to uh, check the local IP. So I have that. So we've got uh, the animations going as well as uh, your responsive UI. Uh, and some animations for the buttons as well, right? And even the toggle switches. Let's see if we can get that closer. Right. So right. So what is the issue if we've got um, uh, a, a driver that can work? Well, let's first take a look here. So let's go to uh, I so I just want to pull up, right? So the issue, first of all, I've got this second board here to demonstrate, and we'll be working mostly with that board, right? It's a Raspberry Pi Pico with the same display as this other one, right? So I have got the display driver from here, right? This is the ILI 9341 display, and I have got this little demo set up right here. So let's see. So MP uh, shot demo, I think it's called. Right. And let's see. That's the thing with MP remote. Oh, okay. Yeah, it actually started. I thought it'll connect to the wrong device. Right. So we've got this going, and what it is pretty much just filling the entire screen with a with alternating colors, right? And just seeing how long it takes to. Sorry, hope you can see this. Mhm. So right, and just timing how long it takes to render that. And as you can see, it takes about 180 milliseconds to render one frame, and that's not gonna cut it for our driver, especially if you want to do animations as well. So we need something better, right? I can get rid of the and you know what, let's add a little delay, and let's only draw one screen, uh, one rectangle. So all we're doing is just going to be filling the rectangle, right? So we start our measurement and we draw, and then I'm just gonna move this up for now just to make it look better, right? And just take a little break after. You don't really need to, but yeah, you know what? Let's just try and do this as fast as possible and see how long this takes, right? So you can see on average it takes about 140 milliseconds to paint the screen, right? And yeah, like I said, that's not gonna cut it, right? Let's go ahead and just put this back, and we can go ahead to our second example, right? So I refactored the driver a bit, and I wrote uh, kind of a superset that supports only MicroPython at the same currently, but it's pretty easy to add the equivalent functions for circuit Python, right? So let's take a look at this. We've got the main difference. Well, okay, I guess let's start simple. Let's start simple first, and then so let's go ahead and so the reason why this is so slow is because it is written in Python, right? As you can see, let me see if I can find the so fill right? So this is the implementation for fill rect, and yeah, so we pretty much go through, and for each chunk, right? We create some a buffer to hold our data, and we fill that. The block function is just allows us to draw to the display, right? And you can see we're doing a whole bunch of unnecessary work, but also we're doing this in Python. Not unnecessary. Well, I shouldn't say unnecessary because you actually do need to do that in order to uh, display anything. But excuse me, my throat is getting a bit dry, right? So there is a better way, right? So micro Python frame buffer, right? So MicroPython also comes in with a built-in frame buffer class, right? And this is implemented in C, and so it is much closer to the hardware, right? And because of that, it gives us quite a bit of performance advantage for no cost, or well, at the cost of memory, right? So I have yep, so I have uh this demo setup. It's doing the exact same thing. We are filling the display, and then why don't we go ahead and run it? So that should be example. Let's see. Right. So already we can tell much faster it is doing this in C or using the frame buffer class rather than the Python implementation, right? The and it is fantastic, right, in terms of like the performance, and I think it especially shines when you so you know, for the other example, right, it was about 117 milliseconds when we took out the center display. So let's just see how much it gets affected, right? Oops. Okay. So, right. Right. So it takes virtually no time, right? And if we just want to see how long it takes to fill the frame buffer alone, see, it takes just about 6 milliseconds, right? About 5 to 6 milliseconds to fill the entire frame buffer, right? So what's the issue then, right? So this works currently when we have nothing else going on, right? If we only just wanted to do some rendering and nothing else, then this is perfect, right? But in reality, most of the time you actually want to have firmware alongside your display, right? And so allocating so let's if we take a look at our example, we need to allocate so let's just pull up a Python console here, and any moment now. Okay, so let's see, just want to sorry about that. Okay, sure. A second. So, for a display like this with a width of 320 and a height of 214, and I'm an idiot. Okay, and so we need to multiply by 2 because each pixel is 16 bits, which is 2 bytes, right? And so we need about 153K for this display buffer, right? And let's go ahead and see how much memory we actually have on the IP2040, for example. Okay, so let me pull up my terminal. Let's go ahead and attach to, right, yeah, this is running. Oh, I should. And what is this? I can do mem free. Okay. There's a neat way to format this. Right. You're not here. Da-da. Okay, so let's amount reset. Let's go ahead and okay, so .gc and let's just say gc dot mem. So, and then let us allocate our byte array. So the array. You actually have quite a bit of memory left. Right. 20 by 40 2. And then gc dot free. right? So you can see, right? Just to render our display, right? We have to give up nearly all of our memory, right? We have virtually nothing left. And also, just so you're wondering, oh, you might think, oh, just realize you cannot see. Apologies. Hope this is better. Okay, right. So I can see after allocating memory for our display, we are only left with less than half of the memory we originally had, right? So this is really not feasible for any kind of realistic project, right? You remember the interpreter has to also compile your code, right? So it has to read your code into memory and then turn that into bytecode, right? Unless you pre-compile and freeze or pre-compile your source code and upload dot mpy files, right? Other than that, you're gonna need a lot more memory, right? So just to parse your source files, right? So what can we do about that, right? And that's where today's stream comes in. Sorry for the long intro, but hope the issue is clear. I know I can be a bit long-winded. I'm still getting used to this, so please bear with me. Um, yeah, hopefully I stop saying so much. I wouldn't bet on it, but right. So what can we do now? One thing you'll notice, I guess, let me just go ahead and let's just create a new file. Let's say frame. Okay. So one thing that you'll notice with the frame buffer class, right? So let's go ahead and set up our display. Right? I guess instead you just go ahead and copy a bunch of this from here. So we've got our SBI display and our driver. Right, let's just go ahead and copy this. Right? And so let's do import machine. What else do we need? And just go ahead and have the editor do that for us. Let's grab these. Yeah, let's just grab this. So these are just the pins and Sorry for the super long setup. I'm already getting lost myself. It doesn't look good. Okay, so we just had to copy off a lot of boilerplate. Maybe I should just copy the entire thing. Right, that'd been easier that way. But pretty much all we're doing is just turning on our display. Let's just sleep for a second, and then sprint. Let's see. And display. So so now we just want to right, nothing is gonna happen because we have to actually call our function. Right. Then we want to call our function. It's just nicely done. So right, we have got our display set up. Right, we turn it on and print hello world, and we turn it off. Right, so to create our frame buffer, right, I'm just gonna go ahead and copy this as well. Okay, so in order to create a frame buffer, let's see if we can just find where it came from. This. Did you hear? Got acquired by Atlassian, and I guess that's the end of that company. Yeah, I don't think they're too popular. Okay. Right. So for the constructor to the frame buffer class, right, we need our buffer, our width, and our height. And so typically that'll be the width and height of the display, or whatever you want to draw to the display, right? For example, maybe you might draw something to a buffer and then also draw that into this frame buffer, right? And that's exactly what we do here, right? So what if we don't want to we don't have enough memory to allocate this entire buffer? Let's import frame buffer. And right, so let's say we wanted to only use half of the memory, right? So all we could do is divide everything by 2, right? So, but that is the equivalent of just, you know, getting rid of this multiplication by 2. Okay. And so what that will mean is our width is essentially cut in half, right? And yep. Is that correct? Is my math correct? Sorry. It's, it's not an excuse. It's like 4 a.m. and I really should be in bed, but when I get this out, so I can just move into other stuff. Okay, so we've got here 320, 240, and 320, 240. Yeah, that checks out. I'm not an idiot. Thank God. Okay. So, right. So we can totally do this, right? And let's just try and render this. So we have render chunk function. It takes our x0, our y0, our width, our height, and our buffer, right? And so here for our width, we can just go ahead and divide that by 2 and let us go ahead and render that. I should move this here, right? So what are we doing? We're allocating our buffer, right? We are creating our frame buffer, right? We fill our frame buffer. That fill, right? Let's just fill it with colors and it looks just 3. Why not? Right? And then we render it and we turn off our display. Cool. Do we need to turn it off? I guess it might to just keep it. I guess it'd be nice to just keep it. So let's give that a go. You can run that. Okay. So as you can see, we've got half of our display filled just as we expected, right? And already let's take a look at our memory footprint. So if we could do that alone, right? We so just gonna copy this and right, so we've saved exactly half of our initial memory. Right now let's take a look at what happens if, let's say, we make this reduce the height by 2 as well, right? So might as well do that, right? Here as well. So now we have made the buffer a quarter the original size, right? So let's give that the run. And right, just as we expected, we've got our nice square right in the corner. And if we take a look at our memory footprint once again, so we went from 156 to 78, and now we take our display, right? So 320, and our height 214, we divide it by 2, and so right, we started at 153K, and now we got 13 excuse me 38K, right? And you've got a whole lot more RAM that you can work with in your program. But okay, so sure, you can draw smaller buffers, but how does that help you? We want to draw to the entire display, right? Yeah, understand that, right? So what we can do, okay, let's take a look at one more thing, right? Instead of drawing the our our square right here, and the or you know, that's fine. Okay, so let's say we want to draw a blue square, right? So buff. So wow, he stops. Can I start? So let's hit 0 0, and let's see. So 320 should be 18 and 16, and then what the color? Let's just go with now again. Okay, we clearly did something wrong. Yeah, what did we do wrong? Let's just make this black. Let's give this a go. Oh, that's weird. So X, Y, and width. Okay. Oh yeah, I remember I had to deal with this. Da, da, da. Off by one. Of course. Anyways, now we can move on. Okay. So we've got our square here, right? And so what if let's just resolve this. This should be 80, this 60, and right. Okay. So we're starting in it right now at 0, 0. Let's move it over to x equals 10. Right. Okay. Let's say x equals 50. Right. All right. So we get the picture. And let's say x equals 60. Okay. Right. So what happens if, so let's say our display width is currently half of a screen, right? So that's 320 divided by 2, which is 160, right? So we got a display width, and yep. And so we've got 160, and the width of our box is 18, right? So if you go ahead and add that up, right, that's 140, right? So we've got about 20 more pixels to go. So let's just go ahead and make this 80 and run it one more time. Okay, so now we're at the very edge. Now, what happens if we make this? Okay, now let's do the same for the height. Okay, you know what? What happens if we make this, say, 90, right? Are we gonna crash? What's gonna happen? Right? So you can see the box moved out slightly, right? So it drew what we could into the frame, and the rest got discarded, right? And let's go a bit more. So let's do 120, and let's run that, and you can see now most of the box is out, right? And we've got the remaining piece here, and the box is still there, right? We can move it down. Let's go ahead and just add, right? So let's move it a bit more. Let's go. Okay, and then let's go 80, and let's see. Okay, so just like before, right? We've moved most of the box outside of our visible drawing area, right? We drew what we could into the box and the rest gets discarded, right? So now, could this help us? Well, so what that means for us is that so in, so what we can do, right, is decide on a fixed size buffer, right? And then what we're gonna do is draw whatever we can into that buffer, right? And once we draw, we move the buffer to our next position and we draw whatever we have to draw over there, right? So, um, how do I put this another way, right? So, um, if let's say our regs, let's say we fill 100 by 100, right? All right. Yeah, we wouldn't see it anyway. 0. Right? So if let's say we wanted to draw a square that was this wide, right? What we could do is draw as much as we could, right, into our current buffer, right? And then we can advance our buffer and then draw the remainder into that buffer, right? And that is pretty much the idea I have implemented in this, right? So instead of drawing the so if we do not have okay, so let's go to where we actually do the draw call, right? So what we do is pretty much figure out where we are on the screen, figure out how much we have to render into the buffer, and we render into the buffer. Maybe as we go ahead and flesh out the implementation, it might make a bit more sense, right? But okay, so it is getting a bit late for me. I wish I could stay and stream a bit longer, but maybe I'll try tomorrow and we will try and just walk through it and also flesh out the package. package. All right, so thank you for watching. My name has been The Trace. Like and subscribe, and I will see you in the next one.